Welcome. In this short video, we will show Akamas application-aware optimization at work. Let's look at the live optimizations defined for a key microservice of the commerce application. And let's focus on the optimization for the cart microservice. The optimization goal is to reduce the cost, which in this case is represented by an already aggregated metric based on the container CPU and memory limits. And there are two constraints representing the SLOs defined in terms of response time and error rate. For this optimization, several parameters about Kubernetes and JVM runtime layer have been selected. In addition to the Kubernetes CPU and memory limits for the container, the optimization scope also includes JVM max heap, garbage collection type, and active processor count as tunable parameters. Let's see how this live optimization has been operating so far. First of all, let's look at the workload dynamics. Represented by the transaction throughput metric, which, as we can see, displays a quite regular pattern. Let's now have a look at the cost metric, which represents the optimization goal. This shows how Akamas has been autonomously decreasing the cost over time. How was this cost reduction achieved? Let's look at the applied configuration by zooming in the area where the cost dropped. And let's also look at container CPU limit and the container memory limit, that is, the two parameters which drive the cost. As we can see, the cost reduction is primarily driven by the decrease of the container CPU limits from about 1,600 millicores to about 1,000 millicores. And now let's also look at the CPU utilization at the container level. As we can see, at some point, the CPU utilization changed pattern from about 1,200 millicores to about 600 millicores. To understand how this was possible, let's have a look at configurations 7 and 8, where the CPU used dropped. The key is that configuration 7 has the garbage collection type G1, which is the default for JVM apps, while configuration 8 has garbage collection type parallel. It is known that by changing the garbage collection type may provide important benefits for some application. Thus, a change of the application runtime layer allowed the container CPU limits and associated costs to be reduced significantly. Thanks for watching this video on how Akamas' ability to optimize both the Kubernetes and application runtime layer deliver higher level of cost efficiency. Please keep exploring other videos on Akamas Live Optimizations.